Sweet, okay. Let me know when it starts.
You may start.
Awesome. This is my 1970 Volkswagen Beetle. Doesn't this look really cool? Yeah, I love it. Anybody ever drive an old Volkswagen? Raise your hand. I know there's a certain generation that everybody and their friend had one. I've had this for almost 2 years. Shortly after getting it, though, sadly, I blew up the engine. It was a very sad day. I had to pull into a gas station, call AAA, and this is what happened. They took it away. So I decided, let me just swap the whole engine, because people can do that. So on the left side, you see the original 1500cc engine, and on the right, a brand new 1600cc dual-port engine. I did this in my garage for these old Volkswagen Beetles. The engine's in the back. You jack it up, you drop the engine out, you dolly it around. I did this with my mom at home. It was a lot of fun. It was a bonding experience. I even painted the heat things on the side and the exhaust system. It's red, it's black. It didn't stay that way very long, but it was shiny for a while. I also did a full interior restoration of this Beetle. Even though the outside, as you saw, looked like it was in immaculate condition, the inside was nasty. It was owned by some 55-year-old guy named Joseph Smith from outside Greensboro, North Carolina. He liked to smoke inside. Ew. So I did everything on the inside. I tore these old panels off, put hush mat inside, put the new panels on. Doesn't it look nice? Yes, it looks very nice. I gutted the entirety of the insides of this thing down to the bare metal. You can see here the floor pans. On the top, you see a nice, fuzzy, soft headliner pad. Then this is me putting the headliner in. It's a nice sand-colored tweed. I had to pop out all the windows and windshields for this thing. This is a very iconic picture of me doing this very laborious work. I spent 4th of July all week last year doing this project. Inside, here's what that headliner looks like. Isn't that a nice color? As well as the what are these called? Sun visors, that nice tan. This is what the full headliner looks like with the new brown carpet to match everything, as well as the new steering wheel. Oh, it is so nice, isn't it? And here's the back seats. I got the insert with the cream color and the tan that all matches. You can see the side panels there, as well as that back shelf. You can see 6x9 speakers if you missed it back here. Under the kick panels, you can see 6-inch speakers as well, the woofers. Underneath this back shelf is an 8-inch subwoofer. My Beetle goes boom, boom. It sounds amazing. I spent way too much money on it. The amplifiers in the trunk, I ran all the lines myself with help from my friend Steven Fetzer. Here's what the old interior looked like with the seats. They were kind of saggy, nasty, icky. It smelled kind of weird. This on the right is what it looks like now. And yes, that is a lucky cat on the gear shifter. 4 on the floor, baby. Woo! This is a picture of it after I finally got it all running and working. I'm in downtown Raleigh here. Doesn't it look nice? Yes. Even my puppy dog, Suki, thinks it looks nice. See how happy she is? Yeah! Oh my gosh, she's so happy. Oh, look at that grin. Yeah, pictures worth 1,000 words. So, we did so well with this Beetle, you know what I did? I went and bought another air-cooled Volkswagen. First I had the Type 1, now I have the Type 2. This is the 1979 Volkswagen Bus, or Transporter, minibus, station wagon, whatever you want to call it. This is the last year they made it of the bay window style. You can tell it's bay window because the windshield is one piece and the windows along the side are long. I picked this up from a guy in Eastern Carolina. This bus had been sitting for a decade or 2 decades or more. I don't know how long, but we scooped it up for a great deal for a cash offer. We had AAA haul it home because I was within the 100-mile limit. Here it is, a true story. Here it is on my mother-in-law's driveway. I did a little bit of things. You can see it's kind of ick. We got the little droopy eyes. We affectionately call this thing the Big Turd. And when we wrap it up, we call it the Big Burrito. Yes, the wheels were really nasty. You can see I love that it was white wall, but unfortunately all the rims were toast. So I had to do the wheels and the tires and everything. I did that myself. You can see my giant jack. I tried saving the hubcap or the wheel rims. 2 of them were totally rusted out. 2 of them I kind of de-rusted a bit and sold them to people on eBay. I actually bought them. It's pretty cool. The door hinge was frozen shut. That sucked, so I had to go figure that out. But now that's working. Also, one thing that happens in those Volkswagens, the floors always rust out. Do you see the floor in there? It's like it was fresh. I couldn't believe it. That's why I bought this thing. It was incredible. Suki wasn't happy with the inside, though it smells like a big turd inside. So that one's still a work in progress. Where do we go next? Oh, am I out of time?
13 seconds.
Okay, then I got a Carmen Gia. Yay, isn't this beautiful? Look at that. I got it from Tennessee. Suki's not sure about it. I had to replace the clutch thingy, but man, glam shots. What's the moral? Oh yeah, the license plate is error. What's the moral of the story? Do things away from your screen. Software isn't everything. Have some hobbies. Go outside. Thank you.
Well, I would need them. I mean, I have to type a lot on my. So
That is why we have the stand.
okay. Yeah, my video's up. I mean, it's up on my screen. Oh, this is my screen. This is not what I'm seeing
I know.
here.
You want to either set it to mirroring or move the window to the other screen. Because it said to accept. Hey, there we go.
Oh, here?
Yep.
Yeah, but now I don't see it myself.
Right down there, you should see what
Oh.
they say.
Okay.
Are you good?
Would be okay. Yeah, I mean that works too.
All right. Make sure you talk to the mic and I will start the timer now.
Okay. First of all, thank you to all the organizers for this wonderful conference. Yesterday we saw an interesting talk by Al about recursive function calls. So I thought it would be nice to talk about recursive data structures in Python and how you can do that. So now I have to look here and type here. So you create, for example, let me put this over here, like an empty list, and now you can append the list to itself. And when the wrapper actually displays it in a meaningful way, it doesn't go into a recursive loop. And the interesting thing about this, if you look at the first element, it just looks like the list itself. And you can do that like as many times as you want. You can actually pickle a recursive list, and you can also deep copy a recursive list. It's made to work like that. Next, we can look at a dictionary. Again, we start with an empty dictionary. Now we just say one entry, none, equals the dict itself. And now we have a dictionary with one key, and the value is the dictionary itself. And again, D of none is that dictionary. And you can repeat that many times. Next, I was looking at tuples. The problem with tuples is that tuples are immutable. You can't just append something or change an element in a tuple, which is true from the Python layer, but it's not true in the C layer, in the implementation of Python. I'm using CPython, by the way, as probably most people here do. So I wrote this little What is going on here? Oh, no, I'm on the... Oh, I mistyped. Control backslash. That didn't help. And we just kill the whole thing, maybe. Bring up. Yeah, I brought up. Oh, here's a big error message now. I don't know where my mouse is. Yeah, but I need it here too. Oh, here it is again. We drag this over again. Make it bigger again. Okay. So here's my C function. It's called recur tuple. It creates a recursive tuple. And what it does, it creates a tuple object with one element. And then it sets the zeroth, the first element of that tuple, to itself, and then returns it. So let's compile this. Let's see what we get from, yeah. And this is my recursive tuple object, which you can only create by tricks. But Python is smart enough to display it correctly. It's not smart enough to deep copy it or pickle it correctly. It goes into a Stack Overflow. And what is even worse, you can calculate hashes of tuples normally, but if you do it with this tuple, something very terrible happens. Okay.
Time's up.
That's it.
Thank you, Ilan. Be careful with recursive data structures. No one needs to open a rip in space-time, okay? Come on up, Mara. The mic is yours. Start your time as soon as you start talking.
All right, so hello everyone. My name is Mara, and I recently graduated from college. Last May, I went to UT Austin, got a degree in computer science. And since then, I've been working for around 9 months in industry, so I wanted to talk a little bit about some of the differences I noticed in industry versus academia. So I noticed differences in lots of different ways, but I'm going to talk about the 3 main ways that I noticed right now. So the first being is the time spent coding. So as a student, we're kind of expected to just sit down and like pump out our code, and we don't really usually have to worry about documentation or anything like that. We're just trying to get our code out the door. Whereas in industry, we have to juggle meetings, we have to juggle documentation, we have to juggle collaborating with teammates, and you're not just always sitting down and writing code, although you are still writing code part of the time, obviously. And then the next difference is coding style. So in academia, like I said, a lot of the mentality is really just focusing on getting your code just out the door so that it can get graded, and so you can turn your project in on time. Whereas in industry, A good coding style is extremely important because you have to upkeep your code base, make sure it's readable, maintainable, because your code lives a lot long after you write it, whenever you're writing it in industry. And then lastly is collaboration. So in academia, especially in the classes that I took, collaboration was sort of frowned upon. You were supposed to work as as more or less like a lone wolf, just writing your own code, getting your own projects done. I mean, you had the group project here and there, but even then, like each of you had your own portion of it that you were working on. You weren't really collaborating too much. Whereas in industry, obviously, you need to be constantly collaborating with like your stakeholders, your teammates, everyone. Discuss the design, come up with a design ahead of time, and make decisions with others in mind. So that's a really big difference. So yeah, I've enjoyed my limited time in industry so far. I've had to sort of unlearn a lot of habits that I picked up in college, but I am glad that I'm picking up these new skills. And I think I'm becoming a more well-rounded developer because of it. So yeah, that's my talk.
Thank you. And she didn't like badmouth her senior developer or anything. Oh wait, that was me. I'm actually the next lightning talk, so I'll start the timer whenever I want since I control it. I actually asked to go after Mara because the topic actually bridges nicely off of hers. Before Mara joined my team, Mara was a college intern on my team, and I was her mentor. I talk to her a lot about books and things like that. I actually like to do for some of the college interns that I mentor a gift of a book or a couple of books that I think are interesting and impactful, something that they can take along with themselves. I'm going to pass on 3. I'll post the links to these books in the Discord after this talk is over. But these are 3 books that were really influential to me, and I think they're good for any professional developer. The first one is this one, Being Geek by Michael Lopp. Does anybody here know who Michael Lopp is? Has anybody ever heard of Rands? He's worked all over Silicon Valley, worked for Netscape, worked for Slack. Right now he's at Apple. Fantastic guy, has a great podcast, talks a lot about leadership and management. This book is a career management handbook for software developers. It covers everything from trying to find a job, going through the interview, starting on a new team, learning communication styles, how to communicate to managers and to peers, all the way up through becoming a manager and up through when to start finding a new gig. How to tell when you're unhappy and ready to move on. This book is fantastic. The chapters are self-contained. You can read them whenever the situation arises. It's a fantastic book and well worth your time. It's also funny, and I like funny. Not that I'm very funny. Second book is this one, A Philosophy of Software Design by John Ousterhout. There is a link here to his talk at Google that he did. It's about an hour-long distillation of the biggest points from the book. John Ousterhout is the creator of the TK language. He is a computer science professor at Stanford. He started a software design course because, as he said, we spend a lot of time teaching young people how to write code. We don't spend a lot of time teaching them how to design code. And good design saves you a lot of code in the long run. This book, my favorite line that I've ever heard is writing working code is the easy part. Anyone can write code that works. Writing code that's scalable, that's maintainable, that's evolvable, that's the challenge. This book is definitely worth your time. It's a little heady, but it's really interesting stuff. It's language agnostic, and I think it's evergreen. Last one is Think Like a Programmer, volume 1 in the series. I love this book because this book is all about problem decomposition. Taking a problem and breaking it down into smaller parts and sharing with you techniques to help you identify those parts, break down those parts, and useful patterns to solve those. This book is fantastic. It's a pretty easy read, and it's a lot of fun. So those are my 3 books that I recommend. I know the first 2 I gave copies to Mara when she was my intern. This third one was a new one to me. I got it off of a Humble Bundle. But since we all have those discount codes for No Starch Press, hey, maybe give this one a try. Thank you. And Adam, come on down. We're down to the last two. Yep, go for it. And I will start the timer once your screen comes up. Would you like the hand mic?
Sure. All yours. Thank you. All right, we're mirroring and everything. Awesome. Okay. So I wanted to talk a little bit about Python on real-world robots because as I was out talking to people over the last couple of days, I've realized that I actually am in what is a fairly niche community, as I've discovered in the Python, broader Python community, which is robotics. So maybe, I think everyone, or maybe not everyone, but a lot of people really like robots and maybe are interested in them. And of course, there seems to be some overlap with programming. So maybe you've used the Lego Mindstorms as a kid, or maybe you even went and you picked up one of these kind of like Arduino or some other microcontroller and tried to figure out how to program one of these guys. And if you've done this, you soon learn a few things. One, these robots are pretty limited. Two, for the most part, it's tricky to program them in Python. But I want to write them in Python. I love Python, so let's do some Python. This is the robot that I work on. This robot's called Moxie. It is significantly more complicated than the one on the previous slide. Moxie is a hospital delivery robot. It delivers supplies to nurses. Things like the one you see here is an IV pump that a nurse is pulling out. So it goes across the hospital, it rides elevators, it goes through doors, it has cameras, it has lidars, it has an arm, it has a face. It's really cool. I love working on it. But how do we go from the little robots on the previous slide to this robot? How do you actually program a real-world robot? Well, it still actually boils down to a few simple steps. You have to receive data from your sensors. Okay, darn it. You do that with C++ or C or firmware because it's a lot of data. Okay, you need to control your actuators. Well, maybe I can do that with Python. Probably not. Probably better to do that with C++. It's real time. It has to be, the motions have to be smooth. Okay, well then maybe at least I can connect them together with decision making. Yes, that you can do with Python. So you might have some sensors, you might have some actuators, and you'll connect them with Python in the middle. And so how do we actually do this? Now we have to get all these pieces to talk to each other in different languages. Enter Robot Operating System, or ROS. The first thing you need to know about ROS is that it is not an operating system. It is instead a multi-language framework for distributed systems. What does that mean? It implements all of the following. It is a publisher-subscriber mechanism. It is a service client architecture. It is a global key value parameter store. It's a message serialization system. It's a build system, and a bunch of other things. And, well, it's kind of exhausting, but what it boils down to is it's a de facto standard for robotic components to talk to each other, including your decision-making system. How many people here have heard of ROS? I see a couple people nodding. Okay, maybe like 10, 15 people. That's cool. And it works in C++ or Python. So there are some robots that don't use ROS, ones that have very high performance needs, or ones that are doing something that's very repeatable and don't need to be particularly smart. But I put an asterisk there because a lot of those robots can work with ROS. People just choose not to. But there are lots of robots that do use ROS, including the cruise self-driving cars, which you might have seen driving around Austin. Those use ROS. You can, again, use robot arms. There's a company in San Antonio that's using them to sort mail and other things. And so many other robots, I could not possibly put them all on one slide. So it wouldn't be, I think, a Python talk without a little bit of Python. So here's some Python. It's actually pretty straightforward to use, at least the pub sub part of it. So you're going to import ROS. You're going to import your message primitives. In this case, we're implementing a kind of a robot that would do a stop-start based on what it sees in its camera. So you'll subscribe to your image, and after you've initialized your node, and then spin is basically just asleep, and it will wait for images to come in, and it will process callbacks when you receive messages on that kind of endpoint there, the camera RGB image raw endpoint. And then we need to implement what the callback looks like. So you have your callback, and then maybe you say, I'm going to publish out something to our motor driver so I know whether my robot should move fast or slow based on what I saw in the image. And of course, not shown here is all the computer vision you have to do. Do the hard part here, but the rest of it, Ross makes it pretty easy to actually connect the different pieces of your robot together. So this is a more complex slide. This is actually from the debug tools that come built into ROS. So I'm not going to go through all this, but you can see how you can build out this system of nodes and topics all talking to each other in order to build out a much more complex robot system. So as I mentioned, we're a niche community, but we're a strong community. We have our own Python and C++ like foundation where we build the open source code, et cetera, et cetera. Please go to ros.org to learn more. You can always ask me questions, allevato.me, or just come find me after. Thank you very much.
Y'all heard that. The robotic uprising needs you. All right, I can think of no better way to bookend this entire weekend than by having Brandon, who started us, be the one that finishes us.
If my graphics card again condescends to, speak to the, oh, look at that. Start the timer so that I know, all right, are we ready, set, go! Many of the things that make me most productive are shortcuts. The things that have advanced my just ability to get things done quickly during the day and not to be filled with rage at how slowly I'm typing or something. Unfortunately, shortcuts are some of the least discoverable of all things. They used to put them in menus where you could see them, but they're becoming less and less popular and less easy to find. For instance, in Chrome, my day is so much faster because I know that Control 1, Control 2, 3 move me directly to tab number 1, 2, and 3 in the current window. So if for example, I always keep my email, Gmail, and tab number 2. So however many tabs deep I've gone doing some research for an email, I can jump right back to the email I'm typing with Control 2. Another very common operation that I was not taught everything about at first is cutting and pasting text. Very often, one of the first things we learn about using the computer is that while clicking moves the cursor somewhere, dragging lets us select a region of text. If we, at the end, kind of miss, here I haven't gotten the whole word measure, I've only grabbed the initial M, we don't have to start over and go back to the top. By holding down Shift and dragging, we can modify the very end of the selection to fix it up without having to go back and find the beginning again. What I was not told initially was that there's a much easier way to grab a selection if I want whole words. If you start with a double click, kind of click, click, hold, then you're now selecting entire words on any operating system I've tried, any browser. And now I don't have to be careful not to end in the middle of a word. I don't have to aim as carefully, and I'm able to move more quickly. I can grab whole words. Finally, triple click is what lets me grab entire lines. This is great for grabbing, because normally when I'm cutting and pasting source code, I want whole lines. And this lets me effortlessly, without having to carefully start at the beginning of one line and the end of another, I can just have my mouse wherever I want and grab whole lines of code from an email, from a web page. So, GitHub. I've been seeing this error all over the place on my laptop this week as GitHub, for the first time ever, had to rotate their SSH keys, and my computers over the years learned that every one of the addresses, the IP addresses on their rotor, their name server rotor for ssh.github.com, all of those IP addresses, it's gradually learned that that SSH key goes with all of those IP addresses. So during the week, each time I look, I use it again, I seem to get a different IP address and get this error all over again. I fixed it the first time or two, and then I just got tired and I just started ignoring the error. But this morning I decided, when it happened again, it needed to be fixed. All right, it tells me that the error is a key in known hosts, line 46. Well, okay, I could go up and maybe, if I'm careful, character by character, try to get exactly that number, and then I'd have to remember the name of a command or write one that would remove the correct line. Wow, that's going to take too long. What if I double click? All right, that's the file name, a colon in the line number. I don't have any commands that will accept that easily as input, and I'd have to remember, type the command. And then it hit me. Triple click. If I triple click, then I get a line which, if pasted into the shell, is a perfectly valid shell command. It has no syntax errors, no asterisks or funny characters that would confuse the shell. It looks perfectly syntactically in the shell like a command named O offending, a space, and the shell will just think the other words are the arguments to the command. There's only one problem. There isn't a Unix command called O offending until today. If you'll go to github.com and look under Brandon Rhodes Home Dir, where I have my home directory, into the bin folder that I keep on my path, you will find there is now an offending command written for this occasion in Python that verifies that the arguments that are on the command line indeed form this error message. It goes into known hosts, makes a backup of the file, and deletes the offending line. The piece de resistance was that I got an error trying to get push this, and had my system self-heal using the error message itself as the antidote. I triple-clicked, I pasted, I hit enter, and I was able to get push. I've loved PyTexas. Thank you very much.